What's up, everybody? Welcome back to another video slash devlog slash tutorial. In this video, if you hear a lot of noises in the background, don't be bothered about it. My wife's still using my computer, my laptop right now, so there's a lot of projects going on during this end of the year. So I'm using my old computer. On this video, I'm gonna show you how to set up like a behavior tree or AI, artificial intelligence for bots and enemies and so forth. So it's not gonna be only a single video. I'm gonna show you how to set up the basic structure right now, but probably are gonna create like multiple videos about it because there's a lot of things to cover, and I don't think I'll be able to cover everything in a single video. I mean, there's a lot of things to cover. So yeah, also I haven't set up the animations for the characters still. So if you play, for example, right now, you see that the character is still like it's just like moving around, not doing anything like the enemy. That's intentional. I saw in the comment in the previous video that people were curious about how I did set up the animation blueprint for my character itself. So I figured that might be easier to later once I start setting up the animation blueprint for the anime itself. I'll figure it out to record a video about it as well. Um, so yeah, basically, first of all, this is my AI enemy, my base, like my base class for the AI. It's a simple class. It doesn't have any like much in it. It just like has the. Let me just open that up. So let me just open the blueprint editor. It's inherited from my main character class, which is intentional. So he has like the whole gameplay ability system inside of it. So I can later add abilities to it. It has the inventory component, so I can add like a couple items later or generate random items. So once he dies, I just drop off those items. And there's also a couple things that I'm gonna cover. Like there's also the combat tags, the health bar, which was something that we set up in the main character. So now, for example, if I play it and I pick it up, for example, a couple clothings and a weapon, maybe you can see that I can kill the character, and you can see that there's like the task bar, the life, and everything is in it as we expected to do. So basically, what I did then was I went back to my C++ class, the festival characters playable, and I found my C++ class, which was the character itself, and then I created another C++ class derived from this one, and I saved that inside of my AI folder called AI base enemy. And this is a simple stuff to do, and then later I just create like a blueprint based on it, which is basically this blueprint right here. Oh, no, that's the pickup, sorry. Which is this basically this blueprint here. So I basically then substitute the mesh, and later I put the animation blueprint that I'll just put here later once I figure that out. But yeah, so that's the initial thing. And then inside of that character itself, if I go back to the enemy itself, header file, you see that inheritance from my main character. I create another constructor for it, and then I specify this behavior tree variable here, so I can later specify what's the actual intelligence that he's gonna follow. So behavior trees are like, there we go. So you can see here. I'm gonna go deeper and deeper about behavior trees in a few seconds, but basically behavior trees, the whole character behavior, what he's gonna do, when and how it's gonna behave. If it's gonna move, it's gonna chase the player, what's gonna do it. But I'll be back to this in a second. So basically, by doing so, by specifying this behavior tree variable here, I can specify then what's gonna be the behavior for my character later. So I just go to the class default on my AI enemy blueprint, and then I can specify the behavior tree later on. For you to create a behavior tree, it's pretty simple. I just create like a folder to save things for better, for better organization. And then I went here to artificial intelligence and behavior tree. That's basically it. Just name AI base BT because it's going to be the basic AI, the basic minion AI for my game. And then later I also create a Blackboard, which is basically what it says. It's a Blackboard full of variables in it. So if you open it up, it's just a bunch of variables that the AI is gonna store and do something with that later. And to create that as well, just go to the artificial intelligence Blackboard, and I name my AI base BB. And then you open the behavior tree and you specify the Blackboard asset as yours. Should be by default this one. But if it isn't your default, just specify it that way, and then you could go, travel among Blackboard and behavior tree this way. Okay, that's pretty cool. Then I went then to my base AI animate and I specify my base behavior tree here. That's why this variable is like this way here. Also, I create this AI perception stimuli source component. There's like a component inside of the Unreal Engine called AI perception. There's spawn sensing, there's others as well, but AI perception allows you to do multiplayer with, like networking calls and etc. I don't plan on doing multiplayer on the near future for this project, but if this grows to a certain point that I need multiplayer, I rather uh, be with the proper component than having to rewrite the whole thing, everything. Okay, basically this perception stimuli component is what it kind of says. These AI character is gonna be using this component to send a stimulus to other AIs. So if it doesn't have this component, basically you won't be able to um, see, hear, and do AI stuff with it. And that's basically it. That the whole other thing is already set up inside of the main character, which is like the whole clothing system. If I want later to add clothing to my AI, the weapons, etc. It also has, if you want to like check out the whole attributes from the gameplay ability system. It's all inherited from the main character, which is pretty cool. So in the constructor of it, I just create my stimulus component, which is just this UAI perception stimulus source component. You need to include a couple headers, so just pause and include those headers if you wanted to. Like this is the CPP, this is the uh, AI-based anime. This is just for me to later, reference the festival character. So that's basically why it's there. Uh, so basically, the stimulus source component is created. And once I create that, I need to register a sense or an artificial intelligence sense for my component. In this sense, I'm only going to care about what the character is seeing. You have like other types of, let me just show you. You have like other types of stimulus as well. So if you want to take a look at that, for example, there's perception, AI, sense, underscore, you can see that there's damage, hearing, prediction, team, touch, and etc. There's other source of stimulus. For example, if the character is stimulated by when suffering damage, okay, that's going to stimulate the character, and then it's going to be, he's going to be activated once he takes the damage. The same goes if he hears a noise or something like that. That's the hearing and etc. So, but I'm only going to care right now for the sight sense, which is what's happening here. Once he sees the player, he's going to chase it. The gameplay is not doing anything right now, but I plan to do a couple things in the future. But that's pretty much it. So the character itself is a pretty simple thing. I just specify what's going to be my behavior tree, and the behavior tree needs to specify what's the blackboard, and then I specify what is going to be stimulating this character sense. Okay, cool. So if you see now, I have a perception stimulus source component, which is basically what I just set up on the constructor. Cool. So another thing that we're gonna need for our AI is we're gonna need like a AI controller. So in the AI, I create this base AI controller, which is a C++ class of the type AI controller. So you can look for AI controller. That's the class. And basically all the magic is going to happen on the controller, like all the perception handling and etc. Like you set it up the source, like the stimulus on the character itself level, on the pawn level, but the whole thing is going to be controlled by the controller itself, which is basically what the control is for. So if you open up now the AI controller header file, you can see that there's a lot of other things going on here. So first of all, I already included the perception types, and I'm going to explain in a few seconds why I did that. But basically, it's just so I could declare a function based on the delegate from the AI perception. But basically what I did then, I create my component. So if I open up my AI controller, you see that it may have like the default things, like any AI controller would have like this path following component, action components, but those three ones are the ones that I just created. So the AI perception component is what's gonna receive the stimulus component and process whatever is receiving by that stimulus component. So the enemy is gonna receive a stimulus. The controller is gonna capture that stimulus and try to process into something useful. So that's what this AI perception component is. So I specify this to only care about the site because as you saw on the enemy, I just cared about the site. So basically I have my AI perception component right here, which is this one. Okay. I also have my Blackboard component and my behavior tree component, which basically is going to search for whatever is inside of my character that I specify into the top of here. I specify my behavior tree, and my behavior tree has my Blackboard asset inside of it. So if you open your behavior tree, you should have your Blackboard asset here. So based on those elements specified on that variable that I will populate through the editor later for different AIs, I'm going to specify different behavior trees if I wanted to. But basically, the idea behind this is I'm going to create the component, Blackboard component, and I'm going to grab whatever is inside of that behavior tree of my AI character. So this Blackboard component is going to be instantiated with this Blackboard right here because it's going to access that uh, behavior tree and grab whatever is its Blackboard asset. The same goes for the behavior tree. The difference is I don't need to go further. I just go to this behavior tree and try to initialize this component with this. So, and this is the site sense. It's also another component. It's just for me to specify later on the AI perception that I want to have only care about the site. I'm going to explain in a few seconds. So if I go to the base AI controller into the constructor right now, you can see that the AI perception component I just created based on the AI perception. There's a lot of headers here. If you want to just pause the video and include it, just keep in mind that. Also, I had to, in order for me to care about the navigation system, which is basically the character moving around and querying those things, I had to go to my target build file and add this navigation system dependency. Otherwise, any function that goes to the navigation system is just going to fail to compile. Uh, so basically, there's a bunch of headers. You can pause the video, but I'm going to focus on the implementation itself. So the AI perception just created the object, like the component, the AI perception component. And then the site sense, I create the UI sense site. And then I specify all the variables for my site sense, which is basically this right here. So this was not set it up manually. I set it up this on C++. So I added this. I create this site sense, which is basically the site config here, called site sense. The site radius was 500. Then later I changed that, but I can actually change this right here directly. But I later changed that into the. I just set this way, so it can be stored that way. Allow success, 900 seconds. Where is it? There we go. And then site radius is basically the site radius, loose site radius, this. Peripheral vision 100 degrees is basically like the point of view of the character. So he will use 9 degrees. He will see 9 degrees in front of him. So otherwise, like he's not gonna see whatever is on his back or something like that. The sight radius and the loose sight radius is basically how far can the character see. The loose sight radius is basically, okay, it's gonna have like a circle around the character that he's gonna be able to see in front of him, but it's gonna have also a second circle that is going to consider like, okay, if it passed these boundaries, I'm gonna lose him, basically. I'm gonna lose the player. The site sense max age is basically how long this stimulus is gonna last. So, for example, he saw the player. After 5 seconds, If he's still not seeing the player, he's basically gonna forget about the player. That's the idea of this. This stimulus is gonna be like it's gonna have a timeout. So if he's not seeing the player for 5 seconds, then he's gonna just forget about it. The same goes for the auto success range from the last scene location. If you leave these as 0, he's gonna lose the player pretty quickly. This is like required because it looks like there's a bug that the affiliation system is just not working properly. So what he's gonna do to detect is basically everything. So just set everything to true, so he can detect enemies, friendlies, and neutrals as well. So whatever is stimulating the AI perception is gonna be used, and then the AI perception is going to set the dominant sense, which is basically what he's going to be like. What his dominant sense is going to be his sight. So he can have multiple senses. He can have like he can be able to see, he can be able to hear, he can be able to identify damage or etc. But the priority sight is going to be this one, which is the sight sense, which is his field. And then I configure the sense for the same sight sense. So this set dominant sense is just setting this variable right here, and this configure sense is doing adding another config sense like this, like so. So now the character has a stimulus for the sight, and the controller can understand that stimulus, that sight stimulus, because it's set up inside of the AI perception component. Okay, now let's go to the behavior tree component. Now the behavior tree component is just what it says. It's like what's the behavior tree that this controller is going to use to control the AI, and what's going to be the blackboard for that specific behavior tree. So if you go to the onPossess, basically what I did then, I create those components like so, and then I override the possess function right here, which is basically whenever the controller possess the player or possess the AI, what I'm going to do then is I'm going to call the super possess, and then I'm going to try to cast this character or this spawn to my AI base enemy, which is going to be my base class for any AI right now. And if that's true, then I'm going to check if there is any behavior tree inside of that class, which also will be true because there is a behavior tree right here. And then it's going to check whether it has a Blackboard asset inside of this behavior tree, which is also true because it has this Blackboard asset right here. And if so, the Blackboard component is going to be initialized with whatever Blackboard asset is inside of this behavior tree, which should be this one. So later on, we can use this Blackboard component to just set values to those, update those variables right there. If that's successful, like if that's successful, we should have a Blackboard to update. Also, if there's a behavior tree inside of the character AI, then I'm gonna use my behavior tree component and start a tree. And which tree I'm gonna start is the tree that I specified inside of my base AI. So it's gonna start these three. And then I am gonna bind, I'm gonna grab my AI perception component, grab this delegator right here, which is basically whenever the AI perception finds something, which on that sense is gonna only be true for whatever he's seeing something, because that's the only sense that I've specified for it. And then I grab this stimulus variable, and that's why I had to import it, because oops, I had to create a function with those parameters, which in this case is solPlayer. So if you see back down here, I create this function called solPlayer, and I had to specify these AI stimulus as a variable. So that's why I had to declare this perception types here, because it was required for this type of variable. So basically, whenever I am seeing something, I'm going to call this function solPlayer. And this function solPlayer is going to use the same delegators as the AI perception component, which is going to have an actor and a stimulus. So if I open that up, so basically what I did is I initiate, once I possess my character, I am going to initiate my Blackboard component with whatever is the Blackboard asset inside of my behavior tree. And I'm also going to start the behavior tree, and then I'm going to bind the saw player. So whenever this on-target perception update is triggered, it's going to call this function saw player because it's what's actually happening. So on that function right here, what I did is when I see the player, I'm going to check whether the player is the actual player, because he could be seeing like any other thing. He could be seeing like an ally, like another enemy. He could be seeing like maybe his minions, or maybe he can spawn other minion or something like that. Maybe he's seeing just like a static mesh or something like that. I need to be sure that I'm only gonna do something if I'm seeing the actual character. So how do I do that? I cast my instigator character, which is whatever he's seeing is this actor. So I'm casting that to the main character class. If that passes, I'm gonna check if that actor specifically is a child of that class. Sorry, I'm gonna check whether this controller class of that character right there is a child of my uh, main player controller. Why is that? Because my AI is also a class from the festival character. As you can see, it's just inheriting from the festival character. So if he's seeing an enemy, this check is gonna pass because he might be seeing an enemy, but the enemy is also a player character because it's inherited from there. So how do I check that is actually the player? I can check that by the controller itself. So if I'm controlling that whatever the character he's seeing, that means that that's the main player. If I'm not controlling, there's going to be other controller, which the AI controller controlling that AI or anything else. And if that checking, so don't pass, it means that he's not seeing the player. But if it passes, he's seeing the player that I am controlling. In that sense, an enemy. So if that passes, I am going to grab my Blackboard component, set a value as a bool, and what's going to be that value? It's going to be this key called enemy visible. And there is a couple constants that I set it up inside of my project header file. And the enemy visible is nothing else but this can see enemy, which is basically this Blackboard key right here. So he's just going to set this variable can see enemy with the stimulus was successful sense. What's this mean? What that actually means is, okay, he's gonna set I saw the player, but if for some reason he lost the player sight, then he's gonna set this sense is gonna be false. It was not being successful triggered. So let's suppose he saw the player, and then the sense died after 5 seconds, as we specified before. He's not seeing the character anymore. He's still gonna update that, but he's gonna update with the reverse of this, which is false because he's not seeing the player anymore. I know it's got a bit confused, but that's how it works. And then I'm gonna set the enemy target, which is just another function that's gonna do the same thing, but it's gonna set this target variable here, which is a type of vector with the actual character to follow. So if you go there, it's just gonna check if there is a Blackboard component. It's gonna set the enemy target as an actor. And the enemy target is nothing else but a variable, and that variable is receiving AI enemy, which is target. Okay, so this is basically to set up the whole thing. Okay. Also, there's a couple other functions that I'm gonna go over before trying to play the AI, but which is this function get next location. So where the player is actually gonna go if he's patrolling. Saw player I just showed, set enemy target I just showed. And there's also this function called get Blackboard component, which is just returning the Blackboard component. So whenever I want to specify a set the Blackboard value outside of the controller, I can just cast at the controller, grab that function, and set the value as needed. Okay, so this is basically the setup. Okay, so first of all, just trying to recap the whole thing. Create a character based on, it can be based on your main character. In my case, I did, but you can just create a character if you wanted to. And then specify a behavior tree element, and then create the stimulus component for it. Once that's done, specify the senses that you want to use for your AI. In my case, I just want to use the sight, which is fine for me. And that should be about it. Now go back to the controller. The controller is a bit more complicated. You're going to need to use the Blackboard component and the behavior tree. So you can grab later from the character that this controller is possessing that variable behavior tree. And by so, you can grab the behavior tree to start so the AI can know what to do. And the Blackboard component, the Blackboard asset, so he can know like which variables he needs to update. The same way, you need to create the AI perception component so you can understand what the stimulus is receiving, and based on those stimulus, you can create multiple stimulus for it if you wanted to and process that way. Those tags are just like Blackboard component tags. If you go to the top of it, you see that there is like a patrol point for this tag, which is just an S location, and the enemy target is just the AI enemy, which is basically this Blackboard assets right here. So next location, you can see enemy target, and etc. Right, then you go back and you unpossess. You're gonna start your behavior tree, or you start your controller, you start your AI the way you want to do it. So basically, I do that by grabbing my pawn, so I can grab my behavior tree and my Blackboard asset, which is basically those two. And then I can initialize my Blackboard with that Blackboard asset, and then I can start the behavior tree component with that behavior tree that I specify. The AI perception component, I bind a delegate to it, so whenever that on perception update is triggered, it's going to trigger the SOP layer, which is my only sense. If you have a different senses configured for your AI perception, you may need to use the stimulus for something else. You may need to use the stimulus to check which stimulus is being activated, and you can do that pretty simply. But so you can check whether this stimulus is a hearing stimulus, if it's a sighting stimulus, damage stimulus, or whatever, and do whatever you want to do based on that function right here. And basically what I'm doing now, if I see the player, I'm just going to set that the enemy is visible and that he's the target to follow. The go to next location function right here, which is the only one that I haven't explained it so far, is just grabbing a random location, a random reachable point location inside of the map, so I can know where to patrol. You can have like multiple classes, like actors, placed on the level, and then there's lots of tutorial on the internet on how to create like static routes for AI patrolling. I don't need that for now. I just want the character to be moving randomly into the level so I can just test it. In my sense, basically what I did is the origin of my player is whatever it is its location. The end location, it's just a variable that I'm going to use to later grab a random value to it. And basically what I do is I grab whatever is my current nav mesh. So another thing you need to consider is you're going to need to place a nav mesh into your level. In my case, I do have one. I just don't know where that is. So there we go. So I have this nav mesh into here, and if you press the key P, you'll be able to see where the AI will be able to travel. If you size that into that specific point, that means that the AI will be able to move around inside of that box. So you're probably gonna need like a huge nav mesh instead of a level, or multiple nav meshes depending on where you know where do you want the character to move to. So basically that's gonna grab whatever is my navigation system or my nav mesh, and if that passes, what's gonna do is get a random pointing navigable radius, which is basically any random point nearby the character based on the origin. The radius is gonna be 600, so it's gonna look for nearby 600 its location, and the results are gonna be stored into this end location variable right here. And then if that it's okay, because that returns a boo, because sometimes it may not found anything nearby. Maybe your character is outside of the nav mesh or something like that. It's gonna fail that, and if it fails, I'm just gonna return like an empty vector. But if it doesn't fail, I'm gonna return the location that I just found, so I can have a next location to go. But yeah, that's about it. I know it sounds a bit scary, but it's really not. So once that's set up, now you can just go to the behavior tree and start playing around with. So in my case, what I did is the behavior tree has a couple rows. You have two main nodes, which is the selector and the sequence. And what's the difference between those two? Uh, the sequence node, he's going to execute everything from left to right. And if something fails, it's going to go back to the initial sequence. So let's suppose I run this way. Let me just remove this one. Oops. So let's suppose I do that. So what this is doing is it's going to try to run the patrol every time. It's going to try to find the random patrol location. It's going to move to that location and it's going to wait. If that failed, let's suppose that passes, but this one failed, what it's going to do is go back to the random patrol. It's not going to execute the third one. It's going to go back and try to execute the first one, and then the second one, and then the third one. It's not going to do all the nodes inside of the behavior tree. Basically, what it's going to do is if one fails, it's going to go back to start. That's what the sequence node is about. So let's suppose he finds a random patrol, but then he can move to that location. So it's going to fail. So he's going to try to find a new patrol and try to move to again. If that passes, he's going to try to wait for 2 seconds. If that wait fails, he's going to go back, find a new patrol, move to the location, and wait again until those three are completely executed. The selector node, on the other hand, is the opposite. So the sequence node stops on the failure, right? So it stops on the failure, reset it. The selector node is the opposite. The selector node stops on the past result. So let's suppose I'm gonna actually play that one so you can see it. You probably will be able to see that the selector node right here, where is it? He stopped right here because he's not trying to execute the first one anymore, as you can see. He stopped on this one. And why so? Because this one passed. So if that passed, then he's not gonna do anything. Okay, he's tried to execute this one. One of those nodes failed for some reason, and this one didn't. So he's gonna keep executing that one. When he's gonna go back and execute this one, once this one starts passing. So selector stops on the pass one, sequence stops on the fail ones. Okay, that's the difference between those two. So if you simulate now, as you can see, oops, let me just go back to the character itself. He's just moving around and it never tries to even the second approach because the selector already found the first one it's passing. I just changed this to remove the scan C to the sequence, but as you can see, the selector stops on the one that passes and never tries the second one because that's the nature of the selector. So if you wanted to debug though, let me just play, that's quite useful actually for whenever we are debugging AI code or something, or AI behavior. So let's play, it could be like on the new viewport, it doesn't matter. So let's suppose you're playing and then you tap the apostrophe keys on the keyboard. If you press the number 1, it shows up the, oh, it actually didn't show up, so there we go. Now it showed up. Look, okay, not sure why, but if you press the apostrophe key, not sure why it didn't show up now. Okay, now it showed up. So if you press the apostrophe keys, as you can see, you can debug the whole AI perception or behavior tree uh, with the debugger view on the UI engine. You just need to be sure to enable that into your project settings. Under the engine AI system, you need to enable the debugger plugin. Once you do that, you should be able to debug by pressing the apostrophe key on your keyboard. I just need to be with that in the camera, I think. So let me just, oops, what? There we go. Uh, it's quite annoying actually, but once it works, it's quite useful. So there we go. Now I can see it though. So you can see like when he's moving, you can verify like the whole behavior, what's the category that's running. So you can press number 1, 2, 3, not 3, 1, 2, 4, and 5 to enable and disable a couple things. So number 1 enables the AI category on the debugger. So the debugger for the AI category, as you can see, it kind of shows you like the basics, like what's the control name, the pawn name that's the AI, um, what's the movement mode that he's doing, and I'm just trying to run away so he cannot see me. Otherwise, it's gonna be just a nightmare. The nav data, the path following that he's doing right now, his item, then his moving, the behavior, the tree that's running, the active task that he's running, and if there is any gameplay task that he's running right now, or the montage if he's playing any of those, which is kind of cool. If you press number 1, then it deactivates. But if you press number 2, then it activates the behavior tree category, which is basically the brain component. So like it shows like what's the brain component of the AI, which is in that sense. Oh, he found me. Oh, he didn't find me. He did find me or didn't. I don't know. Oops. My camera is just broken. There we go. I'm trying to run away from him, but I don't think I will be able to anymore. But anyway, uh, so you can see that the number 2 category on the keyboard, it's showing like what's the behavior tree that is running and the whole path that he's following inside of the behavior tree, which is going from the root, which is the selector node, which is number 0, and then move to player, which is number 8, and then wait, which if you go back to the AI behavior tree, as you can see, that's exactly what he's doing. Selector, move to player, wait, or move to, or whatever. So that's quite useful for debugging. If you enable number 3, you can see like gameplay ability debugger, like on tags, local tags, gameplay effects, gameplay abilities, etc. by the AI. Number 4, it's something that we're gonna look up. We'll be looking briefly into a few seconds, which is basically the EQS system, the uh, uh, environment query system. The number 5, though, as you can see, is the actual AI perception. So this whole circle is his radius, like his reachable radius. Uh, Sometimes you'll be able to see that there is like a purple circle after that circle. So it's kind of hard to see that because the circle is just so big. Let me just try to reduce that so it's more visible. Just go to the AI perception, which is in the controller. Just go back. AI perception. Let me just change that a little bit. So instead of 2000, let's put like 8,000 and 1500. That should be able to give us like a good idea of what's actually going on. Oops, I pressed escape. Oops. Apostrophes, and there we go. Now we're monitoring again. I'm gonna press the disable those two, press number 5. So as you can see now, we have the visibility and radius of the AI perception component. The green circle is basically like the actual, if you enter that green zone, he's gonna see you basically. As you can see now, that pointer showed that he's actually seeing you right now. If you go to the purple in time, he's probably gonna lose you at some point. I think that's actually what happened. He kind of lost me, and now he's run patrolling again. So if you press number 2 again, you can see that his run patrol is the behavior tree node that he's following. But if I go back into his side of view, he's gonna see me, and then he's gonna follow me. And once I'll become able to make him lose me, which is kind of hard with that sight, which is too big, but I'm okay with. Let me just make him go in here so I can see if I can make him give up. I think he's gonna lose me. There we go. He lost me. So now he's random patrolling again. So, and he lost me because I exit his sight into this purple area. He would probably be able to spot me if I got unlucky. But anyway, outside of those boundaries, he cannot see us basically, unless you program your behavior tree to do the otherwise. And this circle dots and etc. Those are just the last location. As you can see, sometimes it shows like let me just try. You can see that there's like age 0, and that's what the max age is about for. So if he loses our side, there's gonna be a timer there, like 5, 4, 3, 2, 1, 0, and then it's just gonna put like it's gonna have like that timeout for the stimulus itself. Bang, get out, bro. So yeah, uh, that's actually how to debug the whole AI and perception system and behavior tree and etc. Going back to the behavior tree though, you can see that sometimes we have those Blackboard based conditions over here. So that's basically what controls the flow inside of our behavior tree. So in that sense, this sequence is only going to execute whether this variable inside of the Blackboard called can see enemy is not set, which means it's false. On the other hand, it's only going to chase the player if that variable is set, which means he's seen the player. Also, if the player is a valid target, it's set as a target so he can follow and move to the player itself. And how you do that, how you actually add those decorators. So you can basically add a decorator here and select the Blackboard. There's a couple others here. I'm not going to go into those. There's like loop decorator, there's like cooldown, time limiter, etc. But what I'm going to do basically, I usually select like the Blackboard key decorator, and then you can select either if it's set or it's not set, or you can consider that either is valid or is not valid for dual pointers, for example. And then you can select whatever the variable you want it to be to set as a condition to run those sequence. You can add those as well into the specific nodes if you wanted to, but I don't know. It sounds a lot easier to do that into the sequence directly or the selectors. Okay, so you can see now that our character, if you simulate that, that's basically just grabbing whatever random point he can find around his 600 radius of the code, which is basically what is specified into the code. Let me just open that up again. I think it's on the base controller. Let me just find the define nav. As you can see, that's the radius that he's looking for on the get next location function. Uh, but how that actually it runs that task over here. This is not like a common node. For example, the move to is a node that you can call it if you wanted to. Like there's this move node ready for wait is one as well. Uh, play animation, which is basically so you can play any montage and etc. is also one node. There's a lot of nodes that you can call that's already ready for you to just call it. However, this is like a task, and a task is specifically is this is a custom task. Sorry, a task is specifically a custom task. You can create either blueprint. This way, you can just click on new task, and you should be good to go. You should be already created like a new task over here, and you just can rename that if you wanted to, and call it that way later. So I'm actually gonna create just so for the sake of this video. So you can create one here. You can call give like a custom description, like I don't know, test, and then give another description called test. Uh, you can call a function, for example, where is the execute AI, and there you go. You can either finish, execute as a success or as a failure. You can do whatever you want to do, and then under here you can just call that. Let's just save that actually. Oops. should be under the task here somewhere. Blueprint base new. There we go. It just rename that properly because on here it auto renamed to the task, which is basically what we specify into the class default. But to find it, it actually look for the actual file name. But anyway, that's a way for you to create a task. However, I don't use too much blueprints because sometimes I need to do a couple heavy stuffs, and that tends to drag performance down. So there's a way of doing that in C++ as well, which is basically what that task is about. This is a C++ task, and you can create one by simply going to C++ classes, whatever you want to save that. I just put in the character AI tasks, and I create these BT find radar patrol basically. And you can create a new C++ class, and the class name is BT task. There we go, BT task node. That's the class. There's also the service and decorators. You can create like new services and decorators. Services is basically like um, something that it's gonna run. Let me just create one so you can actually see that. So override tick AI. There you go. It should be like ticking between a couple seconds. So just class defaults where that. There you go. You can create like a custom script like test, and you can specify like the interval, which is basically like each half a second that's going to be triggered. The deviation is 0.1, which is basically either is half a second, that could be plus or minus 0.1 second. So between 0.4 and 0.6 seconds, it's going to trigger. And what's going to trigger, it's up to you actually. So we can just print the string so you can see it, what's that for. And once you do that, you can just create a service and add the service as here, and you should be good to go. That should be triggering every half a second. And if you play now, as you can see, it's just going to print a bunch of hello each half a second. That's useful for when you need to update constant values, like maybe look for the run the patrol every half a second. Maybe you change the head to run the patrol in the runtime, or anything that needs to be changed into a more uh, speed pace than a task, then wait a task to finish. That might be more useful to you. However, take since that executes quite often, take that with the be careful. Be careful with that because since it executes on tech or something like that, uh, keep in mind that if you do heavy stuff, heavy coding on the service, you may drag performance down because that if you have one AI, it should be fine. If you have two AIs, it might be fine. But if you have like 10, 12, as you scale up the amount of AIs running that same service, each one is going to have their own instance. You may have bottlenecks in your game just because you're running a heavy service that doesn't necessarily need to be run in a service. It could be just maybe a task or maybe a decorator inside of a Blackboard that's a lot lighter for for the purpose itself that you're trying to do. Okay, but on the C++, also those can be created in C++ if you wanted to as well. You can go to the tasks. I wouldn't create a task. I would create like a service, but you should just look for BT service, and there you go. You can find the service. The same goes for decorators. Maybe you are not happy with the decorators from the Blackboard. You can create a new decorator if you wanted to, and it's the same. Check AI, whatever, and the decorator could be added into the checklist, which is not what I'm going to do. Usually I just use custom decorators when it's really, really necessary. I tend to use just the Blackboard decorator, which is fine for what I do mostly. But let's stop rambling. For the task itself, which is basically one task that needs to be executed and then go to the next one, you need to create the BT task node class. And once you do that, you need to override one function only, which is this execute task, which it was that one that I just override when I create that in blueprints. And you just override that with that, naming. And then once you override it, create the definition. And what I did basically was like, okay, grab whatever is my owner, my controller owner. So I grab my controller and I cast to my controller, AI controller. And if that passes, that means that I'm controlling a custom AI of mine. And if that's the case, I might be able to grab the Blackboard from that controller, which is that function gap Blackboard component that I just created inside of that, like that forcing line function inside of my controller, which is just returning my Blackboard component. And with that, I can just, I'm not even use that. I'm probably gonna need to delete that. I don't really need that. So basically what I'm doing is I'm creating a vector called next patrol point. I'm grabbing my next location, and remember that next location is just doing like getting a random point into that radius. And if that doesn't pass, if it doesn't find anything, it's gonna return like a empty vector. And once I get that, I check if that's an empty vector, because if that's the case, I'm gonna fail my find an next patrol because I couldn't find a valid one. So if it's not a valid one, I'm gonna fail. However, if it is a valid patrol point, then I'm just gonna set my patrol point key name inside of my Blackboard, and that patrol point, as you can see, is just my next location. So basically, what it's gonna do is it's gonna grab my Blackboard, grab this variable next location, and it's gonna change with whatever is the next patrol point, which is basically that the return of that function over here. And once that's set it, I'm just going to return x succeeded. So it's a pretty quick and fast task to execute. So it's just going to grab a value set into that next location variable, and then I'm going to move into that new next location. So if, for example, if you simulate that and you go to the behavior tree, you can see that the variable next location is changing constantly. So minus 936, minus 636, and so far, so far, so good. So it's changing. It's a quick task. It changed the value, then it moves to and wait. Change the value, move to and wait, and that's how it should be done. Okay. However, uh, this is not the best way of actually moving your character. I'm just trying to explain how a behavior tree tear down works. So you like, what are the nodes? What are the basic concepts about it? As I explained it before, it's kind of hard for me to cover everything in a single video. So I'm probably gonna have like multiple videos, just like me showing like what different AIs I create for my game, like the skeleton. Maybe I have like a beholder or a mage AI, or maybe bosses, etc. So maybe I'll just explain how I create each one of those if you guys are interested on as I create them. So uh, the best way actually to make a character move into a level is making them aware of the environment itself. Right now, this function doesn't care about the environment. It's not aware of anything that is around it. So maybe you're in a corner that doesn't have a valid radius, like it doesn't have a valid reachable point. So this get next location would always return a invalid location, which is basically a zero, an empty vector, and this would always fail. And if that always failed, you can see that basically there's no patrol, because if that fails, it's gonna go back to the sequence as failed, then go back fail. It never would go to the next one because sequence stops on failing ones. So there is a potential flaw here, which is the AI not finding or getting stuck at some corners or something like that. So for finding route next, like route patrolling or next points to move or etc., I would highly recommend to you guys to study EQS, which is the environment query system inside of the Unreal Engine. So I myself haven't studied that much. It looks like it's pretty simple and straightforward to do. However, it's a bit of a try and error. It looks like it almost looks like it's more of a designer thing than actually a programmer thing. Even though it's programming stuff, it looks like it's more like try and error and figuring out what's the best for each AI or something like that. So you could add like a decorator here, a service, and the service could be run EQS. And the EQS basically what's going to do is it's going to query whatever is the environment that the AI is around, and it's going to use a custom query that you can create and decide what to do with that result
where to store and what to do with that result later. So for example, this query system, it's gonna always return some value, and I'm gonna always return that value as the next location because the query system is usually trying to find locations for the character to move. That's why it's environment query system. It's gonna try to find some paths inside of the environment, most likely, and you need to specify like a query template. So whenever it's the result of that query that you're gonna do, it's gonna store the value directly inside of the next location variable. So in that sense, I don't need that task anymore. I can just create a query, set the result of that query inside of my next location, and then I can just create my query here. You can create environment query by just clicking on that button. I just created one just for testing. And if you open that up, the EQS system, it's pretty straightforward actually. You specify what kind of generated. There's a couple, default ones. For example, the current location, the circle. The circle is basically trying to find the path uh, by projecting a circle around the character itself. The cone is going to project the cone. The donuts in the grid and the pattern grid, as you can see, it is what it looks like. So I basically specify the cone generator, and I change the degrees of that cone to 200, so it's a more wide cone for me to look for. And I think that was pretty much it. Yeah, that was pretty much it what I did. Uh, Also, I add a specific task because if I just do that, it would project a cone in front of my character, and it would find the easiest, the easiest spot on that cone, which probably would be the first and the nearest path or the nearest uh, point of that cone to my character. So my character would be actually it might be easier for me to just show that in action instead of talking. So okay, DQS is just a cone generator, uh, and the result of that cone is gonna store in the next location. So now if you simulate that, let me actually just hit play instead of simulating. Yeah, let's simulate it. Yeah, I cannot debug unless I'm playing. So if I try to debug now, can I debug? I'm trying to pass the processor keys and it's not working. Dang it. It's not working. Okay, almost there. There we go. So now if I press the number 4, you can see that it's just trying to find a path, projecting a cone, and trying to go to whatever the location of that cone is. However, if I do a specific test in here, and the test is a pathfinding, I can already remove, I can on the filter if the path exists, which basically is don't go anywhere that is just unreachable. So that should be the basic scenario. And if I know hit play and just, oops, he'll find me. There we go. And I press number 4. He's just, he's doing the easiest thing as possible. He's finding the nearest spot inside of that cone, which is trying to find like whatever is the most reachable location as possible. And that most reachable location, is safest location to go is, well, the nearest point into that cone that he's projecting. So I want to go make him going to the furthest but also safest location of that cone. And how to do that? I do like I think it's distant, or is it? I think it's distant. There we go, distance secured. I'm gonna filter and score, which means I'm gonna filter the dot on that projection, and I'm gonna score that dot based on a minimal location, which is basically the farther the better the location is. So it's a bit inverted over here, but basically what it's gonna do is gonna grab whatever is the furthest location possible inside of that cone, but still the safest location. I mean, it's still reachable. So if you now do that and hit play and trying to debug the AI, you see that he's going for the nearest and longest cone into the projection, and he's then projecting a new one, go into the new one, projecting, and go into the newest one. If you go, for example, if you had like a as you can see, like he's just passing by the obstacles based on this QA system, and he's not never getting stuck, and also never getting um, going to the easiest solution as possible. And this has like limitless possibilities and limitless uh, achievables with this. So, for example, if you have like a shooter game that needs to, for example, the AI might need to seek cover when engaging into a fight with the player itself, well, that might be how you would approach it. You would need to create a EQS, test that EQS until the point that you can create like a query system that find the better and the best, so the best you should score whatever your projection is doing, and find based on that score what is the best possible place for the character to go, and once it goes there he should be um well getting cover. But yeah, and also the EQS runs as a service, so it runs in the same uh, sequence. So again, it's good, but anyways, be careful with that because it's like a tick. Before you would be able to run EQS this way. However, now that's been deprecated, so you cannot select EQS system. It was awesome whenever we could, but I don't know why they deprecated that. It was just so awesome. Why would you ruin that for us? Okie dokie. Also, another good thing, and let's suppose you have um, multiple behavior trees. Like you have characters that may have uh, the behavior of them might be too big. So let's suppose you have a character that has its own stage, like a boss that has phase one, phase two, phase three, or whatever. Instead of creating like a multiple phases and becoming like really unmanageable, you can just call this node run behavior and select a different behavior tree. So maybe that's the phase one, and once he reaches, I don't know, maybe you can have like a selector calling like life is less than, I don't know, 20% or something. And if that's the case, run this behavior, which is basically, I don't know, danger phase or something like that. And then he could switch. It's he could switch its way to behave to a different phase or something like that. Yeah, so that's the bare bones of it, and how to manipulate a behavior tree with C++ uh, or blueprints or whatever. Uh, I'm gonna see if I can have some time to create a couple examples. Like this is example is just a bare bone one. He's just moving around and following the player if he finds it, but it's not actually doing anything. It's not hitting the player or anything of the sort. As I move along with these behavior trees and this AI stuff for my project, I'm gonna make sure to post it here, like the actual behavior tree output of it and how things tends to behave with that. So that might be useful for y'all that are looking for behavior tree and AI stuff. But yeah, hope you like it.